dark openings are some of the weirdest things out there in space, and scientists are super interested in them. Basically, they're these things with gravity so strong that nothing, not even light, can get away. It's like the edge of what we know about physics. Einstein figured out the idea back in 1916, but we didn't really know if they were real until later. Then, in the 60s, some people studying the Cygnus constellation spotted this star acting strange. Turns out, it was getting pulled on by a dark opening called Cygnus X-1. This was the first real proof that these things exist. Cygnus X-1 is really far away, like 6,000 light-years, and it's super dense. Its gravity is so intense that light can't escape, which is why it's called a dark opening. Since then, we've found a bunch more of them. Our own Milky Way might have over 100 million. Even though they're hard to spot, scientists have found some in our galaxy. There are smaller ones made from dead stars, and huge ones in the middle of galaxies. These dark openings mess with stuff around them and can even change how galaxies grow. If something gets too close to a dark opening, it's doomed. It gets sucked in past the event horizon, which is like the point of no return. Then, it gets stretched like spaghetti before getting completely crushed into nothing at the center, called the singularity. It's pretty wild. Even though dark openings are cool for testing physics, they're still a big mystery. Scientists are trying to figure out how they work and what they mean for space and gravity. They're like these silent watchers in the universe, daring us to figure them out. Even though the closest one is super far, about 1,500 light-years, people still wonder if they could affect us. And get this, in 2021, scientists got the first actual picture of a dark opening. It's called M87, and it's in another galaxy. It showed us that dark openings are more complex than we thought. The picture showed that dark openings have layers. First, there's the event horizon. Then, there's this area where light just orbits the dark opening. And finally, there's the singularity in the middle, where physics kind of breaks down. It's all pretty complicated, and each dark opening is a little different. Since we can't just go to one, scientists mostly study them from far away. They're trying to figure out where they come from and how they act. NASA's been looking at the center of M87 and found a huge dark opening messing with things around it. There are still a lot of questions, but people are working on it. Back in 1963, this guy Roy Kerr had a crazy idea about spinning dark openings. He said they have this area called the ergosphere where things get weird. But the craziest thing was his idea about wormholes, like shortcuts through space and time. The idea is that space is like this fabric, and dark openings can create tunnels through it. It could connect faraway places or even different universes. But, wormholes might not be stable enough to use, and they might not let you go faster than light. But, people are still really into the idea of wormholes. It's like a cosmic doorway, and it makes you wonder what else is out there. So, scientists are also trying to find one theory that explains everything in the universe. A big part of that is string theory. It says that the smallest things aren't points, but tiny vibrating strings. These strings make up all the stuff in the universe. String theory might help explain dark openings and wormholes. The strings can mess with space and gravity in weird ways. But, the thing is, string theory says there are more dimensions than we can see. It's like there's more to reality than we know. Even though it's hard to test, string theory is a cool idea. It connects math and physics and might help us understand the universe better. It's super hard to figure out how quantum mechanics and dark openings work together. But recently, some scientists had a breakthrough using string theory. They found a solution, but only in a simpler version of the universe. It's still a work in progress, but it's a big step. Studying dark openings makes you think about really big questions about the universe. How do they mess with stuff like neutron stars? They can warp space and time so much that they make gravitational waves, which we can now detect. Finding these waves has opened up a whole new way to study space. We can see black holes crashing into each other and other crazy stuff. It's helping us learn about how dark openings are made and how they change over time. One puzzle is what happens to stuff that falls into a dark opening. It seems like the information about that stuff disappears, which messes with quantum mechanics. This is called the information paradox, and scientists are trying to figure it out. Also, huge dark openings in the middle of galaxies might change how those galaxies grow. They might even be connected to dark matter and dark energy, which make up most of the universe. Understanding this could unlock some of the biggest secrets out there. Albert Einstein first thought about black holes way back in 1916, but they were just ideas until we got better tech to find them in the 20th century. A big deal happened in the 60s when some space experts found a strange object in the Cygnus constellation. It was a bright blue star that shot out high-energy X-rays. This star was going around something invisible, which didn't make sense until they figured out it was caught in a hug with a big black hole called Cygnus X-1. Finding Cygnus X-1 was like, okay, black holes are real, and it started a new age of black hole study. Cygnus X-1 is about 6,000 light-years away and has some wild features. It's super dense and has so much gravity that not even light can get away. That's why they're called black holes. Later on, we found a bunch of black holes all over the place. People think our Milky Way galaxy might have over 100 million of them. Even though they're hard to spot, space experts have found some good possibilities in our galaxy. These range from regular-sized black holes made from old stars to super big ones in the middle of galaxies. Black holes mess with stuff far away too, changing how space stuff grows and what happens to things around them. If something gets too close, it's done for. It gets pulled into the event horizon and stretched out like spaghetti before getting eaten by the singularity at the middle of the black hole. This spaghettification thing shows how strong a black hole's gravity is. As something gets near the event horizon, the change in gravity across it gets so extreme that it stretches it out into long strands. The black hole's gravity is stronger than anything holding the object together, so it breaks apart into a stream of stuff that ends up in the singularity. Even though black holes are cool places to test what we know about physics, they're still pretty mysterious. People want to figure out what makes them tick and understand space, time, and gravity better. Out in space, black holes are like silent watchers, calling out to us to check out the unknown and learn more than we thought we could. Even though the closest black hole is like 1,500 light-years away, people still wonder if they could mess with us. In 2021, some scientists took the first clear picture of a black hole, M87, in the middle of the M87 galaxy. This was a big deal because it showed us what black holes look like and how they work. The pictures showed that black holes have different layers, which isn't how we used to think about them. By looking closely at the pictures, scientists found 3 layers inside a black hole. The event horizon is the outside layer, and it's the point where you can't turn back. Once you cross it, gravity is too strong, and you're going in. Inside that is the photon sphere, where light goes around the black hole forever. If light tries to go in there, it gets stuck. At the center of the black hole is the singularity, the last layer. That's where the rules of physics break down. All the stuff gets squished into a tiny point with a crazy amount of stuff in it. Scientists get confused when they try to figure it out because the usual rules don't work there. Black holes are complicated and change a lot, which makes them hard to understand. They're all a bit different, so we can't just put them in one box. Usual science methods aren't good enough, so we need new ways to figure them out. We mostly study black holes by looking at them from far away because we can't get close without being destroyed. If we tried to send anything into a black hole, it would get crushed. Still, scientists keep trying to figure them out. Some ideas about how black holes are made and how they act are getting close. NASA looked at the middle of M87 and saw a super big black hole messing with stuff way out in space. Even with all these questions, people keep trying to learn more because that's just what humans do. Black holes might be hard to get our heads around, but science will keep trying to shine a light on these dark parts of the universe. Roy Kerr came up with a cool idea in 1963 about black holes that spin. It changed how people thought about them. He talked about something called the ergosphere, which is around the black hole. In there, gravity and other forces are balanced, so stuff doesn't just fall in. This area acts a bit weird compared to normal physics, hinting at secrets inside black holes. The coolest part of Kerr's idea was the thought of an Einstein-Rosen bridge, or a wormhole. This could be a way to get to far-off parts of the universe or even other universes. Wormholes use the idea that space and time are connected, like a fabric. Big things mess with this fabric, creating gravity. Wormholes could be shortcuts through this fabric, letting us travel far distances quickly. But, whether wormholes are real and if we could use them is still up for debate. They might not be stable, and other forces could get in the way. Also, Einstein's ideas say that we might not be able to go faster than light, even with wormholes. Even though they might not be real, wormholes are still a fun idea for scientists to think about. They make us wonder about cosmic doorways and other realities, inviting us to imagine the secrets of the universe. People want to find one idea that combines gravity and quantum stuff. This is called the theory of everything, and it would explain all the forces and particles in the universe. A guy named Michio Kaku is a big name in this search, and he works on something called superstring theory. Superstring theory says that particles aren't just points, but tiny vibrating strings. These strings vibrate like strings on a guitar, and each vibration makes a different particle or force. In this idea, the universe is like a big song, with each particle being a different note. One cool thing about superstring theory is that it might explain black holes and wormholes. As strings move through space and time, they can make weird things like gravitational singularities. But superstring theory also needs extra dimensions that we can't see. It's like if you're a fish in a lake, you only see 2 dimensions. These extra dimensions are hidden from us, but they still affect everything. They're folded up so small that we don't notice them, but they might explain why the universe is so complex. The math behind superstring theory has also helped us learn more about math itself. It shows that math and physics are closely linked. Even though it's a cool idea, we haven't proven superstring theory yet. The extra dimensions are hard to test, so it's still just a theory. But, superstring theory keeps scientists interested and makes us think about the possibilities. It's a wild idea that might help us understand the universe better. Trying to figure out quantum black holes has been a tough puzzle for physicists. Edward Witten said that superstring theory is like 21st century physics that fell into the 20th century. But recently, some physicists have made progress. They've found that string theory might give us an answer, but only in a simpler, two-dimensional world. So, the search for a full answer is still on. The search for a theory of everything calls us to explore the deepest parts of space, where what we know and what we think might be true get mixed up, and the secrets of the universe are waiting to be found. Studying black holes teaches us a lot about the universe and challenges what we think is real. The way black holes work with other things, like neutron stars and gamma bursts, shows us how complex the universe is.